Hey everyone, this is me, Edwin Hernandez, and this is for my Lab 1 report for Physics 2. So, the experiment required us to do to hang strips of tape and just doing our experiments on them. So, that meant uh, creating U-tapes that are positively or negatively charged. We didn't know beforehand. Using a tape that was on a table, and then we placed the tape on top of the base tape. We peeled off the U tape, as we called them, and we placed it on to a wall or something else like that. I used a cardboard box, and when you put your hand nearby, you you saw that there was an attraction to your hand. So we did a couple of tests to see what types, if they're positive or negative, the U tapes, how they're attracted, and all that. And we also modeled one part of the experiment was to try to levitate a piece of tape onto a like put a tape on the bottom, place a U tape on the bottom of another U tape that is hanging above, and see how it can levitate one. So here's a code for the hanging one, for when it was levitating. So here we see my constants. This is the 1 over 4 pi epsilon 0 value. This is the Q proton. This is the gravitational constant. I put that scale factor as 0.7 because of how small my distance was. My distance was 0.02 um, meters. Actually, centimeters. Or, yeah, centimeters. These are my functions that I have. Q is the charged particle. Then this R is the observation location in comparison to the charged distance position. It's E, the equation for finding the electrical field of pertaining to the charged particle position, and is the force of gravity. Find the force of gravity using just G, which is 9.8 times the mass of the particle. So for this one right here, we see that we have our tape, which are our dots, which are our spheres, as I could say. Tape 1 and tape 2 have a length of approximately 20 centimeters. Not that. Approximately 20 centimeters. So that's why I put 0.2, because it's in meters and we need to have them in meters. Uh, our mass of our tape, which is the mass per meter, which I have right here, which is 1 gram per 1,000 centimeters, which is 1 meter. Uh, the we print out the mass, which is the table and table two mass. Then over here we have our the force of gravity upon tape two, which is this is the equation, which uses this function. And tape two electrical force is the opposite of the gravitational force, which we could have used the E field to find electrical force. And then we use all these numbers and their magnitudes to find the Q constant, to find the electrical constant. And here's for the arrows to find which areas we move. Running this program, we see that there's our circle here. No, why our circle is tiny. So here is the circles. They should have been bigger. T1 and T2 are mass. The gravitational force of the second tape, which is this bottom one here, the blue one, the blue dot, and no, that's tape 1, and tape 2 is this one, which you can see it has its arrows up top. has a top arrow, which is pointing from the electric force, and the bottom is the gravitational force. And we have our charge PST, which is, for me, it came out 9.33334 times 10 to the negative 9 coulombs, which is very off of certain things. So, a couple of questions that there are, the length of the pieces of the tube are approximately 20 centimeters. Some of them were a little bit bigger, some of them were a little smaller. The smaller ones, as it suggests, it was very difficult to get reasonable numbers. The mass of, well, one of the pieces of tip is 0.2 grams. The distance between T1 and T2 when I was trying to hover was about 2 centimeters. It didn't hover that much. The gravitational constants and all that is pretty much the bombs here. The gravitational force and electrical force, these are pretty much the forces here, in which you can pretty much get the electrical field and multiply that by Q to get the charge particle, the particle charge. And finally, uh, like if the electrons had a positive charge and then the protons had a negative charge, the it would change a bit because certain things will be attracted to each other. Like the U-tips right now, they're probably negative. I assume they were negative because they were attracted to a lot of things. Positive don't attract to quote unquote neutral things. So that's how I assumed it's negative. Um, but certain thing that didn't couldn't fit in my mind because using a pen that I have in my apartment plus a 65% polyester, 35% cotton shirt, I started actually starting to attract uh, the U tapes, and then when I did it with my hair, it started repelling. I don't know what's going on. It should have been the same thing when you're rubbing on your hair and rubbing on your shirt. I don't know if I'm wrong. It like why is it important to handle a charge stays as low as possible? It's because as you start moving it more, the charges from the U tape will start transferring to your hand, and that will be just try to get an equilibrium from your hand to your to the tapes. And over time, if you leave them outside, they'll start to discharge their charges. So that's why. Thank you and have a nice day.